Okay, let's go to exercise 6.4. So this is another theorem. Okay, there's a total of 4 theorems in this chapter. First one we have already studied, Taylor's theorem. This is area of similar triangles theorem. It is doesn't have a particular name, so if the question comes, it'll come like this only. Show that the ratio of areas of two similar triangles is equal to the squares of the ratio of their corresponding sides. So let's see what the question is asking us to first, asking us to do. Okay, so they're saying show that the ratio of areas of two similar. So there's two similar triangles, right? Let's assume it's ABC and then XYZ. So what the question is saying is they're asking us that if these two triangles are similar, then the areas of these two, area of triangle ABC and then area of triangle XYZ. So ratio means divide as it. Whenever you're dividing two things, it's called the ratio of those. Okay, so ratio, it says ratio, so ratio means division of two areas of two similar triangles. Two similar triangles are here and the areas are being divided is equal to, it's equal to the squares of the ratios of the corresponding sides. So corresponding sides means AB, XY. So AB by XY, and it's saying square of the ratios of the corresponding, so square. So square will be equal to AC, this side by this side, AC by XZ, the whole square, equal to the last side by last side. So BC by YZ, the whole square. So this literally what they're asking us to do. So this is actually a theorem. Okay, it is a question to prove Nishina Ahiyase, but then it's actually a theorem. So this is the question in which we are going to prove this, and then later on in the exercises you're going to use this as a theorem, not as a proof. So if in later on in the exercises they give two triangles which are similar, then you can, and they give you one side and they did not give one side and areas are given, then you can find the other side by using this theorem. Okay, so similar triangles as though itu property tangan exert grow. Okay, so make sure you don't get confused over that. So whenever it's a theorem, we know we have to write given and all those stuff. So given, before we do that, let's draw a diagram, right? Like two triangles, simple two triangles. I'll just draw small because we don't, but in different sizes. Okay, let's say this ABC and this is XYZ, DEF, whatever, EF. Nah? So what is given is given triangle ABC is similar to triangle DEF, and then we have to prove area of ABC divided by area of DEF equal to AB by DE square equal to AC by DF square equal to BC by EF square, right? So this is what we're supposed to prove. Given, we can extend it. Okay, let's do the given extension later on. First, let's write construction. We're just gonna draw height of this one, height of this one. Okay, draw height means always 90 degrees. Nah? Let's say this is ABC, DEF, M, and draw AM perpendicular to BC and DN perpendicular to EF. Perpendicular means 90 degrees. Okay, don't forget it. Why did I draw the height? I drew the height because we need area of triangle ABC and DEF, and in order to find the area of a triangle, we know that the formula of area of triangle is half into base into height. So we need base also and we need height also. Base 2 we can find it out, but we need the height. So that's why I drew am by dn. Okay. Now so let's see what we can do first. We need area of ABC by DEF, right? So let's just try to do area of ABC by DEF first. Okay. Area of ABC by area of DEF. Since we need this, I'm just doing this, and we'll see what we can do later on. So ABC, area of a triangle is half into base into height, right? And this also half into base into height. We cannot cut the base and base height and height because they're different, right? So base in case of ABC is BC, height is AM, base is EF, height is DN. So if you look at this and this compare, you have to show that this is either equal to this, this, and this. Nah? So if you look at this tree, it's very similar to the last one. The last one is what? BC by EF, right? And here we are getting BC by EF here, right? So this was, don't do the red part, okay? This we have already got, so we have to somehow eliminate AM and DN, right? So what is AM? AM is this, DN is this. So if I can somehow, okay, because if you look here, this one, this is BC square, this EF square. So if I can replace AM by BC and DN by EF, then it will become BC square by EF square, right? Red part not supposed to be written. So I'm just for understanding. So you can do it with pencil, this part, if you want to, you know, understand later on when you're studying. So this has to be replaced by BC, this has to be replaced by EF. So that's why we have to find a way to replace AM by BC and DN by EF. Now somehow we have to show AM and BC are the same listing. Now so I'll just, therefore I'll keep this on the side first, and we'll work on replacing those two now after keeping this in the side. Okay, AM by EF equal to DN is equation number 1. We'll just keep this on the side. Now the thing that includes AM and DN are either triangle ABM DEN or either triangle AMC DNC. I'll take any one of them, those. It doesn't matter which one you take. Even if you take this, you're correct. Even if you take this, you're correct. I'll just take this for a moment, since that's the first nearest triangle. So in triangle ABM and triangle, since I'm taking the first one, I have to take the first one, right? Triangle DEN. I think we have already done this in the previous exercise, similar to this. We're gonna take AB by DE. Okay, we won't take the first we have to show this it's similar, not before we show that the ratios are the same. So angle B is equal to angle E, and then angle M, or we can say AMB, this A, okay, equal to A, D and E. So this is, what reason is this? AMB and DNE is 90 degrees each, or you can write from construction. No? And why is angle B and angle E equal? It's equal because in the question is given triangle ABC is similar to triangle DEF, right? Now since two angles are equal, so this and this is equal, this is 90, this is 90. Since two of the angles are equal, we can say therefore triangle ABM is similar to triangle DEN. By what property? AA similarity. Now that we showed those two are similar, what I can write is therefore look at these two triangles. I just showed that these two is similar, right? So now I can write AB by DE equal to AM by EN, AM by DN, sorry, equal to, I can write BM by EN also. Nah? So this much I hope you understood. So because okay, let's just write it. So this much I hope you understood. Let's make this equation too. So AB by DE, AM by, if you look here, AM by DN is here. We were supposed to replace this, right? AM by DN. So we got AM by DN here. This is D, okay? But we are supposed to replace AM by BC, not AB. But we got somehow AB and DE, not BC and EF, right? We needed BC and EF, but instead we got AB and DE. So where is AB, DE, and where is BC, EF? So AB, DE. So AB is this one, DE is this one, BC is the long one, EF is a long one. But aren't they in the same ratio? Because these two triangles are similar, right? So, but AB by DE from the figure, okay, AB by DE equal to AC, or the bottom one, let's take the bottom one since we need those, BC by EF equal to AC by DF. This by this equal to this by this equal to this by this. Why? Because triangle ABC is similar to triangle DEF, which is given in the question. Now here we said AB by DE is equal to AM by DN, but AB by DE, which is this exactly the same, is equal to all these two. So instead of AB by DE, I can write BC by EF also, because this and this is equal. Since these two are equal, instead of this, I can write this. So BC by EF should also be equal to AM by DN, right? So if we make this as equation 3, we can say, therefore, from equation 1, 2, and 3. Equation 1 is this. Area of ABC by area of DEF equal to BC by EF is already here, into, instead of AM by DN, I can write AB by DE. But instead of AB by DE, I can also write BC by EF. We can do this in 2 steps if you want, or you can just do it in one go also, doesn't matter. Let's do it in 2 steps so that you guys will not get confused. Or okay, let's just do directly. BC by EF. In our confusion less for me. Okay, instead of AM by DN, I wrote AB by DE, and instead of AB by DE, I wrote BC by EF. So BC by EF, BC by EF. Therefore, area of ABC by area of DEF equal to BC square by EF square. So let's, if I put this equation 4, okay, see, we were supposed to prove this equal to this square by this square by this square, but here in equation number 3, we already said that AB by DE is equal to AC by DF is equal to BC by EF. Itu tinggal already equal as a equation. So if one of them square is equal to the area, then all of them square will be equal to the area, right? Hence, from 3 and 4, area of ABC by area of DEF equal to AB by DE square. I'm just taking the square common, okay? You can write AB square by DE square also, it doesn't matter. Actually, that's way easier. That's more likely how we'll be using it in the exercises with different squares, but it's the same thing, okay? Hence proved. So that's the theorem of area of similar triangles. So let's take a quick review of what we did here, okay? So first what we did was we wrote given, which is two triangles are similar, these two triangles. Then we wrote to prove area of triangle this, area of triangle this equal to the sides ratio square. Now construction we drew height because we needed the area, so length half base into height grow like it, only height draw. And then we wrote the base, we wrote the height. After that, the half of got cancelled. The heights, we needed to replace this by something, so the heights were included in these four triangles. We took any two triangles, it doesn't matter which two triangles you take. I took these two triangles, and then I proved that these two is similar. Since these two is similar, the height ratio will be equal to the sides ratio. So since height ratio and side ratio is same, so instead of the height, the ratio is same. So height, instead of the height, I just put the side, and then we multiply it, it becomes square. So that's how you do it. So the area of similar triangles, matlab, if triangle A, any two triangles ABC and XYZ is given as similar, then without any proof or anything, now you can directly use area of ABC will be by area of XYZ will be equal to any of the side. You can use, if you want to find BC and they've already given XY, then you can do BC square by YZ square, not XY. Okay, so that's how similar triangle property is being used.